Hello guys, in this video we will be doing some proofs. Specifically, we will prove triangles are congruent, or we will prove that corresponding parts are congruent. Let's start off with problem number 27. We are given a couple of things. So the first thing you do is mark those things on the diagram. So angle A is congruent to angle B. All right, so we'll put a little swoop on angle A and B. And the reason, of course, is given. Similarly, we are given that segment AD is congruent to segment BC. Given. Now, what else can we mark? Just because of the way the picture looks. We can mark vertical angles congruent. All right, these angles are vertical angles because they're right across from each other. See the X? And vertical angles are always congruent. So that's what goes on the next line. Please do not say angle O is congruent to angle O. You're going to have to use the three-letter name. So angle AOD is congruent to angle BOC. And that's because these are vertical angles. So just say vertical angles are congruent. All right, or you could say the vertical angle theorem. That should be enough to say that these triangles are congruent because as I look at one triangle at a time, I see that we have two angles and a side. So for my reason, I'm either going to say angle, angle, side, or I'm going to say angle, side, angle. Those are the two possibilities. Well, it's angle, side, angle only if the side is between the two angles. This side is not between these two angles. So it can't be angle, side, angle. So my reason will be angle, angle, side. Now for the congruence statement. Angle A corresponds with angle B. You can tell because of the single mark. And then angle D corresponds with angle C because they're both blank. All right, and that just leaves angle O. Okay, let's do a few more. Wow, this one's totally blank. Okay, let's start with the given is usually good. So we have angle DBA. Angle DBA is congruent to angle CAB. Okay, that is given, obviously. So angle DBA, that's this angle right here. And angle CAB, is this angle right here. Okay, second given, angle DAB is congruent to angle CBA. Okay, given. All right, DAB. So that's this angle right here. And CBA, that's this angle right here. All right, so we're out of given. This is not enough information to prove that the triangles are congruent yet. What else can we mark just because of the way the picture looks? Do you see that they have a shared side? Anytime there is a shared side, you can just go right ahead and mark that. So now I encourage you to focus. Well, actually, let's write down what we just marked. We just marked side BA as being congruent for both triangles. The way you write that down is you say BA, segment BA, is congruent to segment BA. Whenever you have this kind of silly statement that something is congruent to itself, that is called the reflexive property. Not reflective, reflexive. All right, memorize that. Now it's time to prove that the triangles are congruent. We're at the last line. Here's where I encourage you to focus on one triangle at a time. Okay, so triangle ABC is right here. So let's just focus on that triangle, ABC. All right, so looking at the yellow triangle, what do we have marked? We seem to have two angles and a side. That means this will either be angle, angle, side, or it will be angle, side, angle. All right, it'll be angle, side, angle only if the side is between the two angles. And look, this side is between these two angles. So that makes this angle, side, angle. Now we can make the congruence statement. So we will say triangle ABC is congruent to triangle. All right, now we have to put this in the correct order. Here's where it helps that we have a yellow and a white. All right, so yellow angle A corresponds with white angle B. See, the single mark is on A, but then the single mark is on B. So yellow A corresponds with white angle B. So don't assume that A matches with A. This time they're flipped around backwards. Now, yellow angle B, see the double, is corresponding with white angle A. All right, so that just leaves angle D. Obviously, C corresponds with D. All right, and that's it for the proof. Okay, let's just do a couple more. All right, this time they wrote the given down for us, but we have to mark it ourselves. So segment AC is right here, and that's congruent to segment AR, which is right there. Angle L is congruent to angle S. All right, that's all we are given. What else can we mark though? Hopefully you were just thinking about the vertical angles. All right, see the X? All right, these angles across from each other are called vertical angles, and they are always congruent. Whatever you mark will become a statement. So please do not say angle A is congruent to angle A. All right, that's nobody knows what you're talking about. You have to use the three-letter name. So let's say angle CAL is congruent to angle RAS. All right, and like I said, these are vertical angles, so we're just going to say vertical angles are congruent. Okay, now it's time to prove that the triangles are congruent. Look at one triangle at a time. So, for example, look at this yellow triangle here. All right, what do we have marked? We have two angles and a side. So that means this will either be angle, angle, side, or it'll be angle, side, angle. It will only be angle, side, angle if the side is between the two angles. Well, this side is not between the two angles. All right, this right here is the side that's between the two angles. So, since the side is not between the two angles, it can't be angle, side, angle. It must be angle, angle, side. Now, the congruent statement. Triangle LCA is congruent to triangle. So, angle L corresponds with angle S. Angle C corresponds with angle R. And yellow angle A corresponds with white angle A. Okay, on the last two proofs we did, this would have been the end of the problem because often we're simply trying to prove that the triangles are congruent, and we've done that. But this time, we were asked to prove something extra. So whenever you have already proven the triangles are congruent, and then they want you to prove something extra is congruent, the reason is always going to be CPCTC. Now that stands for, all right, let me just write this down, CPCTC. You have to know what these letters stand for if you're going to use them. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That's why angle C must be congruent to angle R, because they are corresponding parts of triangles that we have already proven to be congruent. Okay, I keep saying a couple more, but literally we have two more. All right, we are given that angle A and angle D are right angles. So we can go ahead and mark that angle A and angle D are right angles. Okay, fine, that's given. Now, if two angles are right angles, they are automatically congruent. So we have to say that as a separate line. See, these are kind of a pair. That's why I put this dotted line here to show you how connected these are. So A and D are right angles. That means that angle A is automatically congruent to angle D. And the reason is so simple. Right angles are congruent. Okay, all right angles are congruent. So you can just write right angles are congruent. All right, so anytime you say that this angle and this angle are right angles, the next thing you're going to say is those two angles are congruent. And we've already marked them. Okay, there was a second given though. Segment CB bisects angle ABD. So obviously the reason is given. Now, again, I gave you a hint by making this a dotted line. I'm giving you a hint that this leads directly to the next line. They're connected. Well, so let's think about it. What does it mean to bisect something? Bisect means to cut in half. So focus on angle ABD. All right, so here's angle ABD. All right, so that angle is being bisected. It's being cut in half. So that means that this part must equal this part. All right, whatever we just marked on the picture, that is your next statement. So I have to mark that this angle is congruent to this angle. And again, don't say angle B is congruent to angle B. You have to use the three-letter name. So angle ABC is congruent to angle DBC. Now the reason is Definition of angle bisector. Definition of angle bisector. Sometimes students get confused and put definition of midpoint for some reason. But just look at the previous statement for a big old hint. If the previous statement says bisect, it's probably going to be a definition of bisector for the reason. If the previous statement said midpoint, then it would probably be definition of midpoint. All right. Is there anything that we can mark on the picture just by the way it looks? The shared side. That is going to be congruent for both triangles. So that means segment CB is congruent to segment CB. Whenever you make that silly statement that something is congruent to itself, that is called the reflexive property. All right, not the reflective property, the reflexive property. So that should be enough to prove that the two triangles are congruent. Let's go ahead and focus on one triangle at a time. So we have a yellow triangle and a white triangle. Okay, so triangle ABC is the yellow triangle. What do we have marked? I see that we have two angles and a side. That means this will either be angle, angle, side, or angle, side, angle. Those are the only two possibilities. It'll be angle, side, angle only if the side is between the two angles. This side is not between the two angles. All right, this is the side that's between the two angles. So since the side is not between the two angles, it can't be this one. So it must be angle, angle, side. Now for the congruent statement. Triangle ABC is congruent to triangle what? Well, A is first, and A is corresponding to D. They both have the 90-degree angle. What about B? Well, the yellow angle B corresponds to the white angle B. Okay, that just leaves angle C, yellow angle C and white angle C. All right, last one, guys, for realsies this time. Okay, they wrote down the given for us, but we need to mark them on the diagram. So segment AC is congruent to segment BC. All right, now X is the midpoint of segment AB. How am I going to mark that on this picture? Well, first of all, here is segment AB, so focus your eyes on that. If X is the midpoint, that means it's right in the middle. So that means that this side must be congruent to this side. So look what we just marked. That's what the next statement is going to be. So segment AX is congruent to segment XB. And that's just going to be the definition of midpoint. Some of my students get confused and say definition of bisector. I say just glance at the previous statement for a big hint. If the previous statement says midpoint, it's going to be the definition of midpoint. If the previous statement said bisect, then it's going to be definition of bisector. Okay. Now, this is not enough to prove that the triangles are congruent yet. What else can we mark on this picture that's not already marked? Well, there's a shared side. that's going to be congruent for both triangles. So that means that segment CX is congruent to segment CX. And whenever you make this silly statement that something is congruent to itself, remember that is the reflexive property. Not the reflective property, reflexive. That's enough to prove that the triangles are congruent. If you just look at one triangle at a time, all right, what do we have marked on this yellow triangle? Hopefully you'll notice that all three sides are marked. That is side, side, side. Time for the congruent statement. Angle A is going to correspond with angle B. All right, you can see the symmetry here. These are right across from each other. So A corresponds with B, and then the yellow angle C is going to correspond with white angle C. Yellow angle X is going to correspond with white angle X. Sometimes this is the end of the proof, but in this particular case, they asked us to prove something extra is congruent, angle A. Now, you can bet the reason is going to be CPCTC. Corresponding parts of congruent triangles are congruent. Now, I said corresponding parts. Angle A corresponds to angle B. So angle A must be congruent to angle B because corresponding parts of congruent triangles, of course, are congruent.